Right, so we are looking right now at data distribution, normal distribution, and that empirical rule. Okay, so right now we are going to look at the empirical rule, and you guys should have this paper in front of you. It's going to be very difficult for you guys to do your homework tonight, to follow along if you don't have this paper in front of you. So please make sure you have it. Okay, approximately how much data falls between these two? Between 68%. The one that says data distribution, normal distribution, the empirical rule on the side. You good, Abby? Okay. How much of it falls between all of these? 95. How much falls between all three? 99.7. Okay? So this is all the empirical rule is all about adding some things together to figure out how much the percentages are. So, yes. That was really quick, but I literally had you guys write these three things down. So you already have them in front of you. That's just all it was. Okay? Are we focused? Because I hear lots of chit-chat. Shh. Need you up here. Okay. We're going to do number one, and I'm going to zoom in quite a bit so we can actually see what I'm doing. Okay? We're right here, and this is just like what we just did for the warm-up. The weight of the 50 football players are normally distributed with a mean of 178 pounds and a standard deviation of 8 pounds. So we're going to do the same thing. The mean goes where? Which one of these dotted lines? The very middle. So 178 should be right here. Okay, the standard deviation is 8. What does that mean? You're going to add 8 to get to the first standard deviation, or you're going to take 8 away to get it to the -1 standard deviation. Okay, so this is 178 plus 8 is 186. 186 plus 8 is 194. 194 plus 8 is 202. Okay. 178, take away 8 is 170. Hey, I'm teaching up here. Shh. Shh. No. 170 minus 8 is 162. Shh. 162 minus 8 is 154. You can get both of these pieces right here and take a seat. No. Okay. Shh. Sit down, Cameron, relax. Okay, so we have made all of our points right here in the bottom. Now we can answer questions A, B, C, and D right next to number 1. Okay. What percent of the players weigh between 178 and 194? Okay, so I'm looking right at this spot right here. So that's when I take out my empirical rule. I know I'm looking at this spot right here, so I'm just going to add those two percentages together. Yep. And what do we get? What's 34 plus 13.5? That's why you should have a calculator in front of you and not be on your phone. It is 47.5%. Okay. So if we have this paper right here, we added 34 plus 13.5 because that's the spot on this picture that I'm looking at. Okay? All right. What is the probability that a player weighs at most 170? So that's at most. So it's these three things at the end right here. You guys see that? These three things at the end? Okay, so that's 0.15, 2.35, and 13.5. What do we get? 13.5 plus 2.35 plus 0.15. 1 second, Cameron. So we're literally adding these three things right here at the end. What do we get? 13.5 plus 2.35 plus 0.15 we get 16. Cameron, do you have a question? No. Okay. What is the probability that the player weighs less than 162 or greater than 194? So I need these at the ends. We're going to add together. So it's less than 162. So I'm looking at this stuff over here. So less than 162. Or more than 194. So I'm looking at this part right here. Yeah. Correct. And what do we get? 5. Okay, so we get 5%. Now this does not ask for a percentage. It says how many players weigh between 170 and 186? So what is the percentage between 180 and 186? 170 and 186. 34 and 34, which is 68. So, but it wants to know the number. How many football players did we look at? Let's go up here. How many football players did we look at? 50. So we're going to go 50 times 0.68. Because we know 68% of them are between those numbers, and it asks us how many players, like the number of people. Because when we change something from a percent and we want to use it to find out, we change it to a decimal. So 68% is 0.68, which gives me 34 players. How are we feeling? Do we need to do a couple more examples? Because your homework is all of these. I know. The last one says 34 players. It says 50 times 0.68. 50 times 0.68. Okay. We're going to move on to number 2. No, you need to sit down. I'm not going to. Okay. We're right here. A set of 120 test scores are normally distributed with a mean of 82 and a standard deviation of 5. Hey, are our phones away? Are we focused up here? Because I'll start collecting them and put them in my pockets. Pick up your pencil. Write down what I'm writing down. Are you even on the correct side? Because I'm on number 2 right now. Okay, so the mean is 82. Where does that go? Middle. And then how do I know how much the next one is? Okay, so what's 82 plus 5? 87. And then what's 87 plus 5? And then what's 92 plus 5? Okay. Now we're going to go the opposite way. 82 minus 5 is? Good. 77 minus 5 is? And 72 minus 5 is? Okay. All right. Now we can answer these questions. Is everybody okay with these? I knew they weren't easy to see a second ago, so I want to make sure you got them. No. Okay. A. What percentage of the scores are between 72 and 87? Correct. So what Abby just said is it's this area right here. 13.5 plus 34 plus 34. And we get 81.5%. Okay, so I have a couple people who are answering my questions and other people are not. So are people that are not answering my questions, are you guys okay? Are you confused? Are you playing on your phones instead of listening? I want to make sure that you know how to do this. Josh, you have 2 seconds to put that phone away or it goes in my pocket for the rest of the hour. If you want to keep it, it needs to be put away. Okay. B. What is the probability that a score is greater than 77? Yes. So we get 34, 34, 13.5, 2.35, 0.15. And we get what? Get 84%. Do I need to stop for a moment? Are we okay? Yeah? Yeah, I can zoom out just a little bit. I just wanted to make sure it was clear enough for you guys to see. Wasn't sure what would work best. Oh, this is a good one. Do we have 2 answers or 1 answer? What is the probability that a score is less than 82? So think about it this way. You want something less than 82, so that's all this over here, right? All of this is less. Or greater than 92. Yeah, we're just adding all that in orange that I just did, all of those things together. So that's like 34 plus 13.5 plus 2.35 plus 0.15 plus 2.35 plus 0.15. And what do we get when we add all of those together? Okay, so let me just double check. Because I got a different answer than you, but I think I did mine wrong. 34 plus 13.5 plus 2.35 plus 0.15 plus 2.35 plus 0.15. I get 52.5. 52.5%. All right, the next question says, Josh, you can't then go to sleep. I told you to put your phone away so you actually listen to me and watch what I'm doing. Okay. Awesome. About how many students scored outside 2 standard deviations of the mean? So remember what 2 standard deviations is. We look at these 2. So I need to add these percentages together. 2.35 plus 2.35 plus 0.15 plus 0.15. We get 5, right? So that's 5%. How do I change 5% into a decimal? So if I want to change 5% to a decimal, it's not 0.5 because that'd be 50%, right? So it's 0.05. Good. And then we're going to times it by the number of test scores, which, just like Abby said, was 120. So 120 times 0.05 gives us 6. Times. 120 times 0.05. And we get 6 people. Okay. I do want to do one more before I let you guys do your homework, okay? One more. I got 6. 6. 120. No, 6. 120 times 0.05 is 6. I bet you put 0.5 instead of 0.05. Just make sure you type it into the calculator correct and you'll be fine. That's kind of the problem usually, right, Abby? Okay, one more and then I'll let you guys do your homework. The price of a gallon of regular gasoline is 75 gas stations is $2.05. Wouldn't that be nice if the average gas was $2.05? Okay, the standard deviation is 4 cents. So we have to do $2.05 plus 4 cents is $2.09. $2.09 plus 4 more cents is $2.13. $2.13 plus 4 is $2.17. Miss Murphy speaking. Okay, I will. Yep, bye. All right, now we're at 205. We're subtracting. We get 201. And then we subtract from that, we get 197. Shh. Go sit down. Stop playing with your phone. And we get 1.93. I'm almost done. This is the last problem. I said that out loud. Okay. A, what percent of the gas station sells a gallon of regular gas for less than 197? So it's this over here. Those 2 spots. 2.35 plus 0.15 gives us 2.5%. Just like Aaron said out loud. Okay. What percentage of a gas station sells a gallon of gas for at least $2.17? 0.15, yes. Shh. What is the probability that a gas station sells a gallon of regular gas for less than 197 or greater than 205? So we know we want all of this up here and all of this down here. When I add it together, what do I get? Just add them. Once you add all those together, you add all of those spots. 1, 2, 3, 4, 5, 6 spots. I get 52.5%. Okay, last one. About how many stations sell a gallon of regular gas for no more than 201? So it's all of this percentage right here, right there in pen. So that's 13.5 plus 2.35 plus 0.15, so that's 16%. So I'm going to change that to a decimal, 0.16. And I'm going to times it by 75, the number of gas stations. I get 12 gas stations sell it for less. Okay, you do not have to do number 4, but you do have to do 7, 8, 9, and 10. 9 and 10, you're going to have to make your own picture.